spaceship is a rocket that once in space folds itself nearly in half to re-enter Earth's atmosphere. This was an ingenious design that first debuted on Spaceship One back in 2004. It's hard to improve on such an innovative design, but together with Bell, I think we've done just that. The mechanism that changes the spaceship's configuration during flight is the most innovative and defining aspect of our spaceship, and we call it the Feather. I'm Gabriel Williams. I'm the Senior Chief Engineer for Spaceships here at Virgin Galactic. There are a set of two core structures that make up the Feather. First, the feather booms, and second, the flight control surfaces. The structural feather starts out with the feather booms. It includes the torque tube, which is what helps keep the structure in one piece as it rotates up. And then the flight control surfaces, including the horizontal stabilizer, the rudders, and the elevons, which are a surface that controls pitch and roll, combining the functions of an elevator and an aileron. There are two configurations our feather changes to. First, the feather raises upwards by 60 degrees when the rocket motor shuts down. Second, the feather moves back down into a glider position, or defeathers as we call it. This provides a very controlled way to land back on the runway.
My name is Sam Brick. I'm the build manager for the Virgin Galactic program here at Bell. As it's launched, the feather is down and stowed, and it's acting like a winged vehicle. But as it transitions into space, where you don't have any air to push against any longer, the transition of the feather up into the vertical position allows the spaceship to tip over backwards, which gives the astronauts on board a really awesome view of the Earth through the windows above them. And then, as the spaceship descends back into the Earth's atmosphere, the air starts to automatically align the feather so that the spaceship is oriented with its belly downward.
Why is the feather so important? It comes down to the three C's: control, comfort, and cost. First, there's control during re-entry. The beautiful thing about the way that our vehicle feathers is that when the feather raises, it configures us in a high drag configuration, which helps us efficiently burn off energy and reduce our speed as we're re-entering from space. It also provides a way to come down to re-enter the atmosphere in a very controlled way, because the feather design means that you'll always come down on the belly when the feather rotates up.
This is really important as it picks up speed and starts to gather heat. When you re-enter the Earth's atmosphere, you want to disperse that heat across as much surface area as you can in order to keep any one part of that spaceship as low temperature as possible.
The second C is for comfort. For our astronauts during the descent phase, when G-forces are building up, the feather makes the vehicle decelerate at a very high altitude where the atmosphere is thin. Not only does this mean that the forces in the vehicle are less at this altitude, making it smoother, the reduced force is also more comfortable for our customer. And third, cost. The feather allows us to drive down the cost of human spaceflight because we're able to land like a plane and pull right into the hangar and fly again in a couple of days. And we have designed it to fly 500 times or more, making it highly reusable. There are many aircraft that change configurations during flight like that. One is the V-22 Osprey. That's a vehicle designed and built by Bell. It takes off vertically like a helicopter and rotates its propellers 90 degrees, and then it becomes a plane. So we knew that Bell would be comfortable co-designing and building our feather system.
Bell has many manufacturing centers of excellence across North America. We're in our Fort Worth facility, where we have several here. We have our Advanced Composite Center, which is where we're sitting right now. We have our Rapid Prototyping Center, and then we have our Manufacturing Technology Center. All of these centers in Fort Worth are contributing to the Delta spaceship, as well as our facilities in Mirabel, Canada, which is a composite center of excellence. So they are building several of the detailed composite components that will feed into the boom and feather.
The spaceship boosts at Mach 3, which means it has huge aerothermal heating. And then coming back from space, all that energy that you're dissipating, it also generates a lot of heat. Well, Bell is experts in this material technology called BMI. It's a very capable material at high temperatures. That's great for us because it allows us to reduce the weight of our thermal protection system, and it also makes we use a very fast application system. And they've given us a great jump start at making these kinds of structures.
I'm Glenn Isbell. I'm the Vice President of Prototyping here at Bell. Our Mirabel facility, just north of Montreal, They're really our BMI expert or our high temperature composites experts because we blow exhaust on our tail boom, so we have some similar needs for some composites that will withstand high temperatures in operation. We're used to big pieces of the aircraft rotating during flight with our tilt rotors. The ability to put our expertise and skills in to do large high temperature composite structures design, we were able to kind of put that on the table and share with the Virgin Galactic team. So we were able to learn from each other in a pretty great way, I think.
As the chief engineer working on the spaceships, it's extremely comfortable to be working with Bell. They have these centers of excellence and a lot of experience working with the BMI. We can leverage that to learn from their processes and leverage their facilities to quickly work through problems. The Feather not only has to be able to withstand heat and be light, but also we're building a line of spacecraft. So we need to be able to build a production vehicle, and we can definitely learn from Bell in productionizing our processes to build many Feathers.
So Bell is functioning as the design team for the Feather, and Virgin Galactic is still the design authority for the spaceship, which means Virgin Galactic has the final buy-off for everything that goes on this spaceship. It's really important that we're tightly coordinated with any changes that we may need to make, because ultimately we want to create something that does not take artisanal work to put together. We want it to go into production. We want it to be a spaceship that's easy to build. We're working with the designers and we're helping Virgin Galactic build this really cool next generation of spaceship.
Bell has 12,000 aircraft in service around the world. They know how to create safe, durable parts for the long haul, and we know how to return people to space. This is how we build a one-of-a-kind feather system, and this is how we build spaceships.